Hello viewers, welcome to Elimu TV where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 3, Lesson number 36. Our title is Law of Conservation of Linear Momentum. The objectives of this lesson are to state the law of conservation of linear momentum. Number 2, to solve problems by calculations. And what does the law of linear momentum state? For a system of colliding bodies, the total linear momentum remains constant, provided no external forces act on it. And momentum before collision, the momentum before collision is the same as momentum after collision. Momentum before collision is the same as momentum after collision. That means mv is the same as mu. Example, a car of mass 1000 kilograms is traveling at 5 meters per second. It collides and joins with a 1200 kg car travel at 3 meters per second. Calculate the velocity of the cars just after impact. Momentum before collision is the same as momentum after collision. m1 v1 plus m2 v2 is equals to m1 plus m2 times v3. Why is it that the total momentum after collision is going to be the summation of the mass of the cars times the velocity? Is because after collision the cars become a one body. Therefore we assume that their mass is the total mass of the two cars. Therefore in this case it's going to be 1000 times 5 close the bracket plus 1200 times 3 close the brackets is equals to 2200 times v. That is the sum of the two masses, 1200 plus 1000. Therefore 2200 v is going to give us 8600. Therefore v is going to be 3.9 meters per second to the right. Elasticity of collisions. We have elasticity of collision. We have elastic collisions. An elastic collision is one in which both kinetic energy and momentum are conserved. An elastic collision is one in which both kinetic energy and momentum are conserved. An inelastic collision is one in which momentum is conserved but kinetic energy is not. An inelastic collision is one in which momentum is conserved but kinetic energy is not. And those are the examples. As you can see, we have differences between perfect elastic and perfect inelastic collision. Kinetic energy of the objects is conserved, while in perfectly inelastic collision, kinetic energy is not conserved. Examples: atomic behavior in Rutherford scattering, and the other one in perfect inelastic collision is subatomic particle behavior in deep inelastic scattering. In elastic collisions, if a body of mass m1 and velocity u1 collides with another body of mass m2 and velocity u2 moving in the same direction, so that the new velocities after the collision become v1 and v2 respectively, the kinetic energy is conserved. In inelastic collision, also known as perfect inelastic collision, the total mass is the sum of the masses of the individual bodies, and the bodies end up with a common velocity. Therefore, we can see that after collision, bodies may, number one, fuse and move together in one direction. Number two, they may separate and move in different directions, or they may separate and move in the same direction. Those are some of the applications of momentum. As you can see, those are some of the application of momentum. It is applied in rockets. It is applied in rockets and jet propulsion, the law of conservation of momentum. A rocket propels itself forward by forcing out its exhaust gases. The hot exhaust gases are pushed out of an exhaust nozzle at high velocity and gain momentum in one direction. The rocket therefore gains an equal momentum in the opposite direction, therefore causing the rocket to thrust forward. The rate at which the momentum changes provides the forward thrust of the rocket. A rocket uses liquid hydrogen as its fuel and liquid oxygen for combustion. It moves faster in the outer space where there is no air resistance than in the Earth's atmosphere. A jet engine works on the same principles as the rocket engine but requires air, which provides oxygen for combustion. The jet engine also requires a large mass of air to push out of its exhaust nozzle so as to provide a greater thrust. Therefore, you can see that in rockets and jet propulsion, the law of conservation of momentum is required. And that is the end of our lesson. And a question. A bullet of mass 10 grams traveling horizontally at a speed of 100 meters per second embeds itself in a block of wood of mass 990 grams suspended from a light inextensible string so that it can swing freely. Find A. The velocity of the bullet and block immediately after collision. B. The height through which the block rises. Our reference comes from KLB Book 3, 5th edition, 2019. For more information, contact us on our phone number, YouTube Elimu TV, Facebook Elimu TV, Twitter at Elimu TV_KE. Thank you for watching Elimu TV. Stay tuned.